Okay, guys, this last video is about covalent compounds, naming and writing formulas. And by covalent, we mean that we have a compound that's only made up of nonmetals. Nonmetals only. And usually, guys, when metalloids are involved, the type of bonding is covalent. If you look at like the electronegativity difference, it's usually smaller than ionic. Um, so I don't want you to get confused with that. So for covalent, the naming and the formulas are a lot simpler. All you have to worry about are these prefixes. So you have to know what these prefixes are and what number they stand for. So when they give you the name and they ask you to write the formula, you literally just say, okay, what's the prefix? So dihydrogen means two hydrogens because di means two. So I would write hydrogen, the symbol, with a little two. And then mono is one, oxide is oxygen. So one oxygen. So water is the common name for H2O, but this would be the IUPAC name for H2O, dihydrogen monoxide. All right. Next one, if there's no prefix on the first nonmetal, that's because there's only one of them. So we only use the prefix mono on the second nonmetal. If the first one there's only one, we just say the name of it without anything at all. Then I have tetra, which means four hydride hydrogens. So I have four hydrogens. So guys, notice, and we're going to get to naming in a minute, notice that the second nonmetal still ends in IDE, just like with ionic compounds. Okay, so don't let that confuse you. The good thing is we don't have to worry about polyatomic ions here. So you're just looking for nonmetals and how many of each there are. You also do not simplify. So there's not an example here where it can be simplified, but if you did get an example where you could simplify the subscripts, you do not do that. You go with the prefixes that were given. Now for naming, so again, guys, you're just going to use prefixes, and the second thing has to end in IDE. But you have to be careful because if the first thing is just one, like how there's just one sulfur here, we're not going to say monosulfur. We're just going to say sulfur, and that the fact that there's no prefix means there's one. 6 fluorines, so 6 is hexa, and I'm going to make fluorine end in IDE. So sulfur hexafluoride. Right. CO, so carbon, there's just one of them. I don't use a prefix. But for the second thing, you always need a prefix. So to say there's one oxygen, I say monoxide. And guys, you don't want to put two O's next to each other. So that one O goes with the mono and it goes with the oxide. You don't have to write two. All right, last one, 2 nitrogens, dinitrogen. 5 oxygens, pentoxide. So I know the prefix is penta, but again, you're not going to have like two vowels in a row. If you spell that wrong, that's fine. But if you see it written somewhere, don't think like, oh, pent doesn't mean 5 because it doesn't have the A in it. All right. All right. So I'm going to give you guys some practice, and then when you come back, we're going to talk about acids. Okay. So acids are confusing. They're complicated because they are covalent, but they act ionic. So when you take an acid and you dissolve it in water, it actually breaks up into ions, even though acids are made up of only nonmetals. So what happens, how you know that something is an acid, is it replaces the positive metal with a hydrogen ion. So here I have sodium phosphate, right? It's an ionic compound. I have a metal and a polyatomic ion. This is phosphoric acid. They took out the Na, the sodium, they put an H there. Hydrogen is in group 1. It does become a positive ion, but it's not a metal. So acids are like in this weird category of their own. They look covalent, they act ionic. There's a totally different way of naming them and writing their formulas. Okay, so let's take a look at the rules and examples. If there's no oxygen in the acid, so see how HCl has no oxygen? You know it's an acid if it starts with H. Okay, I'm going to say the only exception is water. Water is not an acid, and we all know that. So otherwise, if there's an H in front, you can safely assume it's an acid. So if there's no oxygen, you start the name of the acid, the prefix has to be hydro. So right away, I see no oxygen. I'm going to put a hydro here. And it has to end in ic. So what's the other thing bonded to the hydrogen? A chlorine. So if it has to end in ic, I'm going to say chloric acid. So no oxygen, hydro, and ic. If there are oxygens in the acid, you have to think about what the name of the polyatomic ion is that's in the acid. So for example, HClO3, ClO3 is the polyatomic and the name of it is chlorate. So now what you have to do is remember I ate something icky. If the polyatomic ion is 8, you're going to name the acid with an ic ending. So I'm going to name this chloric. The 8 changes to an ic acid. There's no hydro because there's oxygens. You only use the hydro when there's no oxygen. All right. ClO4 is perchlorate. So I ate something icky. I would call this perchloric acid. So again, you need the names of these polyatomic ions, even though these are technically covalent compounds. And then remembering those endings will determine how you change it into an acid name. Ite, if the polyatomic ends in ite, the acid has to end in OUS. So ClO2 is chlorite. So ite has to turn to us. Chlorous acid. ClO is hypochlorite. So I would name this hypochlorous acid. All right. What I would like you guys to do, it's actually, I should show you guys how to do this on your own, because we didn't really talk about going from the name to the symbol. So you know what I'm going to have you guys do? I'm going to have you guys name these acids at the end of this Edpuzzle, and then we're going to talk about going in the other direction in class tomorrow. All right, I hope you guys have a good day.